Robert Julian Wojciech Williams, a towering black man, was working in his Detroit office one day when he received a call from the police. The message was simple. He was to be arrested effective immediately. Dismissing the call as a prank, Williams returned to his home 1 hour later, when he was greeted by a wailing police car, arrested and detained in front of his wife and children, held in jail for over 30 hours, and released only due to the fact that there wasn't any evidence. Why? Because the facial recognition algorithm misattributed his driver's license image to one of a criminal. Facial recognition. One of the most coolest technologies out there. How amazing is it for a computer to look at an image, say, oh wait, I know that person. Facial recognition has many uses around us, from Apple's Face ID to Facebook's AutoTap. Projections show that it will skyrocket in the future. However, facial recognition is biased. Today, we're going to understand the biases behind facial recognition, firstly by understanding the technology itself. So, how can computers perform facial recognition? To simplify this complex buzzword, let's break it down into two parts. Facial detection can be the detection of faces in a digital image, while facial recognition can be the attribution of a detected face to a person. Let's tackle the first part, facial detection. So, how can a computer solve this? The answer is simple, the hard cascade method. It works on a simple premise, that all human faces look alike, and I don't look like a bird, and you don't look like an alligator. Most simply put, a hard cascade looks at a point on an image, draws rectangles around that point, calculates the pixel intensities in those rectangles, and adds it up to show the differences. As you can see here in this image of Elon Musk, this is exactly what a hard cascade would be doing. Now by itself, a single highlight feature, which is a single set of rectangles, isn't that useful. When compiled, tens of thousands of them provide the fast, efficient, and accurate hard cascade, which can be used to perform facial detection in real time. Let's look at an example of this in action. Well, if you can see here, it looks like the computer is successfully detecting my face and also drawing a box around it, and it's working in a live video stream. Great. Looks like we've successfully tackled the first part of facial recognition, facial detection. Now, let's move on to the more interesting part. How can computers perform facial recognition? We need to understand that there are a lot more intrinsic values which the computer needs to compute. You can't simply use a generalized hard cascade. So, what can we use? We can use the LBPH method. The LBP in LBPH stands for local binary patterns. Most simply put, local binary patterns use a thresholding operator to bring out the texture of an image. If you were to use the LBP operator on an image of the Colosseum, this is the image which you'll be getting. As you can see, it is representative of the texture, which means the bumps, the planes, the ridges, etc. The H in LBPH stands for histogram. Histogram is a graph which shows the distribution of pixels in the image. Don't worry, I know graphs are very irritating, and we don't really need to do anything. The computer calculates it based on formula. Wait a minute. So far all we've done is convert an image like this to this to this. How does that make any sense? In the first image, even a baby would be able to understand who that person is. In the last image, even my math teacher wouldn't be able to make sense of it. Well, the thing we need to realize is that we're trying to make it easier for the computer to compute a face. By converting an image to a histogram, the computer can compare two histograms using methods like chi-square or absolute value. Now, all a computer needs to do to perform facial recognition is take an image, extract the face using hard cascade, texture the image using an LBP operator, create a histogram, and convert that histogram with pre-existing histograms to perform facial recognition. Let's look at an example of this in action. A great thing about the LBPH and the hard cascade operator is that it can be performed in real time. Wow, it looks like a computer successfully performing facial recognition. Now, not only is it drawing a box around my face, it is writing my name in the top left corner of the screen. Great. It seems that we successfully tackled facial recognition. Now that we've understood the technology aspect behind this topic, let's move on to the biases. Hold up. How can these mathematical formulae and all these computational algorithms be biased? Surely they're a set of numbers and notations, etc., right? Well, you're absolutely correct. Many times, the bias is not in the formulae themselves, but in the data set in which these formulae train on. If you were to create a Hoyer cascade, for example, and the data set that the cascade is training on contains too many images of one gender, of one race, of one ethnicity, the computer will no longer be computing whether I look like a bird or if you look like an alligator. It will be more about how similar do I look to a specific race, gender, ethnicity. A study by the NIST in the US confirms this claim. In a vast study which they created on two algorithms, one UK academic and one Chinese, it is seen that American Indian females and males are misattributed 60 and 50 times out of 10,000 people, respectively. This shows the bias which is already existing in commercial and academic facial recognition technology. So, how can we solve this bias? There's three things we can do. Number one, we can do better data labeling, so the computer itself won't become biased when calculating data sets. Number two, we can open source our data sets, meaning we can understand, so the entire world understands exactly what we're training on. And finally, we can open source an algorithm to be scrutinized by experts all across the world. To conclude, facial recognition is biased. All facial recognition we do, also artificial intelligence and machine learning, will be biased. The only way to eliminate the bias in the computer is to eliminate the bias in ourselves as a species. Thank you.